Special thanks goes to our gold sponsor, Accenture.
All right, that's very kind. I would not say I share my knowledge. I oftentimes share my lack of knowledge. But I'll do my best today to share a little bit of experience anyway. So with that in mind, my name is Sean. I work at a company called OneGraph. It's a GraphQL service. You'll see how it kind of ties in here and how it was inspired in many ways by the experience of using GraphQL from Reason. That said, I have a lot of background. I worked for years in Clojure. I worked on the ClojureScript compiler. Done a lot of Rust and Reason stuff, shipped to production. I believe we were the first company to ship Ohm to production. If you guys are familiar with ClojureScript, we were also the first to ship, I think outside of Messenger, a full Reason mobile app. And I built stuff that handled money, and so I really care about correctness, generally speaking. So that's kind of where I'm coming from as a frame for all of this. And with correctness in mind, one of the nice things about typed languages, right, they promise you that it is more difficult to represent incorrect programs, right? This is oftentimes the thing of making invalid states impossible. And that's a really nice promise, but the effect of that, the thing I actually care about is I want the promise that I'm going to be happier, right? Whenever I have bugs in my code, I am unhappy. When things break at runtime and I have a hard time tracking it down, I am unhappy. And if I'm unhappy, I become far less productive. So even within a typed system, like Reason or Haskell or OCaml or whatnot, there are problems, there are challenges, right? It can be difficult to know how to represent some things. So the famous example is the original version of React. React was actually prototyped in standard ML. And it worked out very, very well. Jordan Walk did a lot of good work on it. However, he came to the point where he was trying to model, I believe, the state transitions, the update function. And he couldn't figure out how to represent this in the type system. So there are times where you do run up against a wall and you feel less productive, even within these systems. And going further down that road, there are some valid programs that are actually impossible to represent inside of a type system. So the type systems are very, very restrictive in many ways. However, like within that type system, if you adhere to those rules, it's a beautiful world, right? You know that you're never forgetting a variant, right? We probably all hit the variants yesterday. The exhaustive pattern matching is amazing. If I change a file, even like a small signature of a function over here, I know way on the other side of my project that I broke something, and I can fix it immediately. I don't have to wait until runtime. I don't have to console log things. Everything comes to me inside of my editor. These languages, so these domains, they tend to focus on one particular kind of program, right? Haskell is really good for writing compilers. OCaml is also quite good for writing compilers. And it's a lot of work to actually get a language and a type system to really efficiently and productively model a different kind of domain. And you usually see this as like an initial spike by some kind of super heroic effort, something like Jordan Walk doing React in standard ML, or the initial version of Reason. And then it's followed by a lot of polish and a lot of work. I think Chung has talked about that quite a bit. Reason itself has focused very, very heavily on expanding a particular domain. And this is for making building web UIs very, very efficient, to the point where they have literal syntax, like JSX, to describe trees, because this is so common inside of UIs. We have very, very thoughtful people, I think you can agree, designing the state transitions for the components to make sure that that is as amenable to reasoning as possible. And we have very, very nice things pushed down to the language, like routing, to make the libraries as interoperable as possible. The challenge, however, is, again, as soon as we step outside of the system, right, everything is internally consistent inside of Reason. And that's wonderful, inside of Elm, inside of Haskell. But as soon as you step outside of that, as soon as you hit a database, as soon as you hit an API or any other service, all of that beauty goes away. A ton of like unsafe behavior, a ton of unsafe data now enters your project and enters your program and introduces a lot of hard to reason about states. One of the symptoms of this, I think, is definitely unreasonably typed. So these are really, really great projects, but if you look at them, you can see that they are kind of best effort, right? One of the big problems or the big challenges with definitely typed or reasonably typed is they're oftentimes very shallow. And this is how I'd always do the bindings, right? I only bind exactly what I need. I'm not here to bind every library, typically speaking, or every function inside of a library. What's more dangerous, however, is they can be wrong, right? Oftentimes, the Bucklescript compiler will trust me whenever I lie to it, and then I find out to my own chagrin later that I lied. And the other problem is that they don't age well, right? You have a static binding to a library that only is accurate at the moment of its writing. And as that library moves along, as the dependencies get updated, there's a very good chance this is going to fall out, but it will still be used as the canonical binding. Maybe something like rebinding will make this, I think, significantly nicer, however. And to think about, like, definitely reasonably, like, these are for libraries, right? These are for things that we are going to link into our own programs, right? This is not like we're stepping out of the system super far. This is like, we're talking to our roommate or something. As soon as we step outside of our room, like, we have all this danger that is facing us. And I think the bigger challenge here is that, while libraries and ecosystems are very, very important, there is basically no company right now which builds all of its own services, right? Whether that's a database or a payment processor or A/B testing, you're using some external service. And how do you talk to that service? Almost always it's through JSON, right? This is the lingua franca of today. And in Reason, we have this beautiful type system, right? We have this record type called a person, and it has 2 fields. And to us, that looks very, very similar to this JSON record down here. In fact, with maybe a dot, that could be a Reason object. But obviously, for Reason, right, if you've ever tried to kind of take this JSON and get it into the Reason system, it's really, really challenging. And going the other way is also challenging. Let's take a look at what it would actually take just for these 2 fields. I just want these 2 fields, all right, with no magic. If we're using just the raw interop and parsing, this is my parse person function, right? The first thing I have to do is look inside the dictionary and pull out a field called name. That may not exist. If there is a value, I now need to decode it as a string, and it may not be a string, and then I can finally get the value. And I can repeat that for the second field. So these 2 fields here translate, if you write it straight out, into this huge block. And then finally I get my nice record out, and I'm safe inside of my Reason world again, but it's a lot of work, and it's also very, very dangerous. You can see I do not handle these failures very carefully. At least we were able to parse it, and we can clean this up, right? This is actually from some real-world code that I used, where we can basically just say, all right, if it isn't there, I'm going to throw an exception, I'm going to decode it, and now it's down to only a few lines. So this is better, right? We've made some progress, but I'm going to show a more real-world example. And I want to make a quick shout-out to Matush. So he had a tweet, I think back in 2016, saying, in 2017, we were going to be building our UIs in Reason and OCaml. And so the code I'm going to show you is from a real-world app that handled money with lots and lots of users that we launched in 2017. So good job, Nostradamus, like the Polish Nostradamus. So this is basically the same example as before, but this is the real-world example. I have a type of gift card, and it has some fields which are also sub-records. So I have to split out all these different record types, and I'm combining them together. And now my parse gift card JSON, this is as clean as I can make it, more or less. This is with, I still want to retain as much safety as possible in terms of the type system. There's no object magic, there's no coercion in any of my code. But I am trying to make it as succinct as possible. And you can see that this is not super nice, right? I do have to make into floats and all sorts of kind of crazy things. And I'll show you, this is our app. This is the file that handles all of the interaction between the server and the client for this app. And this is back from 2017. So this is the authentic, original syntax. But you can see that this thing is huge. There's so much parsing going on for all these different responses, handling different promises, all this stuff that's really, I'm just shuffling data back and forth between the server. And the crazy thing is, all of our errors, every error, runtime error that we had, happened in here. Because the data didn't come how I thought it was going to be, because I missed something, or because the server had changed. And so even though I had tried to keep all of the code in here as much as possible, it still wasn't enough. I still had runtime errors, right? And actually, I developed everything locally, and I had some dummy data. And this is what I mean by, as long as I was inside of the Reason world, I was super happy, right? I had my native data structures, and as soon as I went to hook it up to the server, it was painful. But even with all of that code, we can metaprogram a way out of it, right? As long as the fundamental system is safe, even if it's verbose, we have some really nice metaprogramming tools inside of OCaml and Reason. So bucklescript even gives us JavaScript converters. So as long as you can JSON parse that string and you get an object back, bucklescript will give you a way to convert from that JavaScript object straight into your record. So like, who cares what the underlying thing is doing there, right? Because all we have to do is annotate our record and say, I'm going to convert back and forth between JSON. So this is really nice. This handles a lot of issues. But the challenge is we still have to rely on the server sending us well-formatted JSON. And if you control the server, this is maybe not so outlandish, but you'd be surprised at how little you control the server, even when you control the server. So one of the challenges, so actually inside of bucklescript, they have a section on JSON in the docs, in the manual, and it has this section here, this caveat. It's in bold, and it says, technically, the correct way to handle JSON is to recursively parse each field and handle invalid data accordingly. Yeah, that is not going to happen. No one is going to do that. I don't know if you saw that code I wrote. I was not handling invalid data properly. I was throwing exceptions, runtime errors everywhere. So really, the truth is, in reality, we have to trust the server sending us the correct JSON. And oftentimes, these services are not terribly trustworthy about it. And the other big problem is, this requires me to enumerate all the fields and to build out the records ahead of time. I have to know the shape very, very well, even when there may not be good documentation on what the shape of the response looks like. So this is from a real-world API. This is GitHub's API. Their new one is in GraphQL, but their V3 was REST. It was very RESTful. And this is, I can't even get all of the response in here. This is a huge response just to get a repository information. So if you are to convert this into the reason record syntax, this is going to take you a while. However, I didn't really mind that. And I thought, if your first instinct is like me, you're like, all right, we can do code gen. We can generate code that will do this for us. So in ClojureScript, but you could do this in JavaScript, I just wrote a little tool, and it walks over the JSON, and it looks at the key name, and the type of the value that's there. And then we just, literally, as I'm walking it, I just spit out to the console the reason record definitions, the type definitions. So given some JSON, I can get my type definitions out. So this is lovely, right? But if we look at this response, do you guys see what changed here? Right? There's a null field. Right? Because the example I gave it was not exhaustive enough. If I had generated the types from that first example, I would have missed it, and I would have had a runtime error right here, probably later that night. But we can make this a little bit better, right? Maybe instead of taking a single definition, what we do is we make a tool that takes lots and lots of definitions and walks over all of the types, and every time we visit the same key, we take a look at the type of the value that's there, and we kind of keep a set of all of the types that we've witnessed there. And type witness is a technical term that I don't know what it means, but I thought I would point it out for each key. So now we have this kind of intermediate representation. We have an idea about what all the types could be for all the different records and all of the different fields. And also, if we hit a key that's a subrecord, because we can't define reason records in line, we can't have subrecords in line, we're going to have to extract those and then also give those names and type them. But this is all doable. And so the hope here is that if we have sufficient number of examples, and that whatever sufficient means for you may be different, and for how varied and crazy your API might be, but we can catch all of the variation and we can go ahead and encode that. And because we have this intermediate representation, we can generate lots of cool stuff. We can generate the reason type definitions. We can also generate reason object definitions or TypeScript interfaces. We can do lots of cool things. So I'm going to show you a demo for ATD Gen. Real quick, this is actually the full size of that GitHub repository response. It is huge. So this is a tool I wrote that does exactly that. You can give it some JSON, and we're going to walk through all the keys, and then we're going to we have an in-memory intermediate representation, but we're as quickly as possible going to generate ATD definitions. And ATD Gen is something you guys should look into. It's a really, really cool project by Martin Jambon in Mountain View that it is a way of representing all of your type definitions in one place and then generating the final client for all the different, for Java or OCaml or for JavaScript or wherever. So I'm going to go ahead and hit this, and it's going to convert it. And you can see here that we get these nice type definitions. So I can see time zone is one of these sub objects in here somewhere. And I get, all the field names are there. And because I have that intermediate representation, I can also do a cool thing where I can generate, this over here is old syntax, but this is valid reason syntax for a GraphQL resolver. Given this JSON, I can copy and paste this GraphQL code into my server, and I have a GraphQL resolver that will handle this server's API response. So this saved me a lot of time. You can imagine pasting in fact, it's always dangerous to do a live demo unplanned, but let's try this. Let's see what this looks like. So if I paste this in and I convert, you can see this is a lot of type definitions here, and this is a lot of code that I would have it write by hand. So it's really, really nice to be able to have this intermediate type definition, to be able to programmatically access the type definitions of the kind of data that we're working with. All right, so now we have tools that can parse all of our stuff. They can generate all of the boilerplate. We still get all of our type safety, right? We're almost there. But here's another response, and I will just guess that you didn't see what changed here. But a field was moved. It was called gist URL, and at one point, they decided to change it to a different key. And this happens more frequently than you want, right? A programmer gets a bout of OCD, decides that they're going to clean things up once and for all, and all of us suffer. And so this is really dangerous, right? The server changed the code definition, but we didn't know that. Our code examples that we have still use the old definitions. Our code in runtime is still expecting the old definitions. So this changed, and now we have this super brittle system where we have to decide, what do? Do we go and gather more examples? Do we get another 1,000 examples? Do we just maybe make this one tweak? And the other big problem is we don't know what else changed, right? This is a good way to become a paranoiac. You will be freaked out about anything changing, right? Because if one thing changed, there must be other changes. So I would say that there are three really big problems for Reason whenever it's interacting with the external world. The first is the boilerplate that's involved in converting between JSON, the external world's representation of this data, and our internal representation of this data, right? It's nice to have records and to be able to spread and only update individual fields. The other big problem is with the confidence and the accuracy and the safety, right? Although we may be able to handle it and there's a lot of boilerplate, even if we did all of that, there's still this really big danger that we got it wrong, that we didn't cover all the type definitions, that we didn't realize that a field was nullable. And then finally, the servers can change without us knowing. It's a very fluid world at times. And so they may not give us any warning, and we will end up suffering quite a bit. Tracking down API changes from the result of responses is one of the most painful exercises, right? If you don't have access to the source code and you don't know what else has changed and you have to derive it, oof. All right, so I would argue that what we want in Reason, whenever we're interacting with the outside world, is a way to access all of the data types in the API we're dealing with. We want to make sure that we have an automatic way of converting between their representation and our representation. And if we're not converting, we want to make sure that we have an automatic way of accessing it, right? Maybe we don't convert it to a Reason record, but we still want to have a typed way of interacting with all of the JavaScript fields. We want to make sure that it's all safe as well. We want to make sure that we have a guaranteed contract. Whenever I'm interacting with your service and you promise me that you have this field here and that it's not nullable, I want to be able to rely on that. And we want to do all of that in a way that is automated. And that's really important so that we can build those kind of tools like ATDgen that generate all of the clients and do cool things for us, things like rebind even. So in a way, I would say all four of those things end up describing GraphQL. So let me show you the GitHub GraphQL example. So the GraphQL world does a great job with tooling. This is a tool called Graphical, and I'm going to do the same exact query that we would have seen beforehand. So I'm inside of a user object right now, but what I want to do is go ahead and pull out the repositories for this user that I'm logged in as. I'm going to pull out the last 5 repositories, and for each of these repositories, I'm going to get the name. So if I run that, I jumped from the user over to the repositories, and I pulled out exactly the data I needed. And if I need more, I can go ahead and add this. I get autocomplete, and I can run that, and I get the data back. So I did way more work I accomplished way more work with far less effort than the REST API would have required me to do, and I got only the data I needed. Right? One of the reasons that repo response is so big is because people really hate the additional work it takes to go and make another separate call. Right? I got a user's repo ID, and now I need to make another call to the repo endpoint to get the repo information. And so people were saying, please put this field over here inside of this repository. I just want to hit one endpoint and get as much data as possible. But the more fields you put in there, the more you cause everyone else to suffer. Right? If I have to download, if all I need is the name and description of every repository, and I get this for every repository, this is terrible. Right? This is a ton of data that I am forced to download and deal with, even if I don't need it. So GraphQL handles kind of both the overfetching and the underfetching problem, and also makes access to all this stuff very nice. And along those lines of programmatic access to the type system, there is a standard way of querying a GraphQL server and saying, hey, what types do you have? What are the names of your objects? What fields do they have? What types are they? Are they nullable? Give me a description of them. And because of this, so this is literally the introspection query. It's cut off a little bit. But every GraphQL service exposes this, so you can query and introspect it. And the response comes back just in JSON. Right? This is even easier than that intermediate representation that I had to build up crawling over the JSON file. So we can literally just query in a GraphQL server, say, tell me all about you, and I'm going to use that to generate some cool tools. So the cool thing here is that we can take the GraphQL's type system, which is very programmatically accessible, and we can marry it with the ReasonML type system, which is really where we want all of our safety. And one of the cool things that we can do here, so I'm going to show an editor demo. This is what it's like to work. So some of you may have seen this if you were at the workshop yesterday. But this is what it's like for me whenever I'm interacting with our API. So I literally have my GraphQL query in line here. I go into GraphQL, I type it out, I get what I want. And you can see here that I have a query that's parameterized by email, and the string is an optional string. And right now everything's OK, but I'm going to make that email a required argument. And I do that by making a bang here. And as soon as I do that, I see that the component that's making use of that query is no longer valid. So I have to go there, and we get to use the features of the language, like labeled arguments, and I get to use that right in line. And so now I know that my query has been fulfilled, that it's both syntactically correct, that the server has these fields, and that I'm executing it correctly. And then from there, we can also make use of the features of the language. So in this case, for example, I'm going to switch off of the status of the response. Right? This is not a thing. This is a thing you need to do out of convention, and you can forget to do very easily in something like JavaScript. But in Reason, we can wrap it in such a way that that invalid state is impossible to express. The only way I can get to the result of this query is if I go through the loaded state. And I'm forced to handle both the loading and the failed state. So in this case, I go ahead and pull out the result, and I parse it into my huge Reason object here. And you can see I'm asking here at the type, or for the type at the bottom. And just in line, I can say, what is the result of this query? And I can see that this is a JavaScript object, or a Reason object that has a me field. It's of JST type. It has an optional full name somewhere down there. And so now as I interact with this object, I get to just use it as if it were a local object, even though I made this call to a server, even though I interacted with the outside world. I'm forced to deal with all of the knowable fields, so I know that there's not going to be any runtime errors. If I make a typo here, if I thought it was name instead, and I hit save, as soon as I hit save, it's going to say there is no name field here, right? So this is what we're used to whenever we deal with Reason level tooling. The problem is we usually traditionally only get that inside of our world for anything that we've defined. And with GraphQL, we can actually reach out into the real world and bring that safety, bring that convenience, and all of those definitions inside of our editor directly. All right, so on the front end, to summarize, what do we get whenever we marry GraphQL with Reason? So we get extremely powerful clients. This is from the kind of the GraphQL side of things. We have the ability to get exactly what we want, no overfetching, no underfetching. The other cool thing is that we have extremely reduced latency, right? And this is particularly important for mobile clients, where you make a request to get maybe a repository ID, you get that back, you then make a subsequent request to get the information on the repository, and you have lots of back and forth. And this is huge. This is bad for battery, and this is really bad for time to first rendering for mobile clients. And on the reason side, we get a safe client. We know that if we have an invalid query, that if we try to access a field that the server does not support, it won't compile. If we try to use a field in the wrong way, if it's an integer and we use it as a string, it won't compile. And we'll have the exact error right where we try to use it. Anywhere that nullable fields are enforced, we will have to deal with it. Some of you may remember the pain from yesterday of dealing with GitHub's nullable fields. Raise your hand if you enjoyed that experience. Oh, there you go. Perfect. Yes, at least some people. It's perhaps better than the alternative of hitting it in runtime. And then this is kind of cool, where it's a very rare thing where we get both the power, the security, the safety, and the performance, and it's easier, right? Traditionally, all these goals are at odds. And the first thing to go is typically either performance or safety or easiness. And in this case, like describing the data I want from these external services inside of my Reason client is much, much easier than the alternative of building up that JSON parser, or of generating types, or of even using automated tools. And so if you were curious about like how would you actually do this, the steps to do this, to get started with this with Reason React are incredibly simple. So this is just from the Reason Apollo README. Basically copy and paste this, you'll get a new Reason React app up and running with Apollo. And there are a lot of NPM packages there. I don't know if you noticed that. So I'm very, very happy about how well BuckleScript integrates with NPM world. That would be terrible to rewrite all of that. Then you send that introspection query, that same query that we just saw beforehand. This is going to send it to the server, the GraphQL server that you're working with. Yesterday we used GitHub's GraphQL server as an example. And it's going to take that JSON response and just store it as a file. And now all of the tooling is going to use that file from now on. So we create an Apollo client. We get our client, our query in line. And you'll notice this right here. This is a PPX. This is a preprocessor extension. This is how we do metaprogramming in Reason right now. And what this is going to do is at compile time, it is going to read this string. And it's going to parse this as a GraphQL query. And it's going to use that JSON file that we just got as a result of the introspection query, and it's going to look up the type. For every field that we're at, what type is it supposed to be? Does this exist on the server? And then it's going to actually generate that crazy Reason binding for us. Right? Instead of us having to like type out the type, this is an object with this field and optional that, it's going to generate all of that from that programmatic response that we got. And then finally, we get to render it. We're forced to deal with all the states, and we can render it right in line. All right, so that's on the front end, and that's where I am the biggest fan of GraphQL, but someone has to implement a back end if you want to enjoy all of those benefits. So the challenge here is that as server developers, we need to remember that, although front-end developers can sometimes be bothersome, they are the ones making the product, right? They have real needs. They're trying to be productive. They're trying to make sure that they're not crashing at runtime. And they want to make sure that the APIs that they know are going to stay stable and not just break in the middle of the night. So we want to provide some guarantees to our clients, right? We want to be honest. If we say that we're going to return an int here, we'll always return an int. And if a field is not nullable, if we don't tell our clients that it's nullable, we will never return null. And ideally, you do this at compile time. So GraphQL.js, the node implementation, will do this check, but it will do it at runtime. As soon as the response is about to go back, it will check to make sure that it's conforming, and if it doesn't, it'll throw an error. All right? So ideally, we just want to get this all out of the way at compile time. So that's the Reason implementation. That's where Reason comes in here. And the challenge is to kind of adhere to all of these points, even when your schema is growing and you have this huge schema like GitHub's, or as your team is growing and you have people who are working on different parts of your schema, different parts of your API. And in particular, one that resonates with me is whenever it's Friday at 7:30 p.m. and you're just going to push this out real quick. And you want to make sure that you're not lying at that point. So we use OCaml GraphQL server, and this is by far the best GraphQL server in the world. Right? I haven't used any others, but this is definitely the best. And this is what it looks like. To create a GraphQL server in OCaml that is type safe, that has all of the benefits that we talked about, this is what it looks like. I'm defining a user here, so I've opened up the schema up there. That's going to provide me with all of these nice functions. You can see that user is a GraphQL object, and I'm providing the name of it that's going to be rendered in all the tooling, the description of it. And this is exposed inside of tooling like this, where I can just click on what is the repository, and I see the definition right here, the description, and I see all of its subfields, and I see the definition of those fields. So all of this is going to be defined right here. So a user has a name, has a field that's a name. I give the documentation for it. I'm promising that this is a non-null string. And this is a really hard thing to actually guarantee, because as your code changes, you don't realize that you returned a nullable thing, except in Reason, where it's not, right? As soon as you return the wrong thing, Reason will tell you, hey, this is a nullable string, or this is an integer. You need to fix it. All right, so I'll talk about some of the limitations of the current setup. So on the front end, that GraphQL PPX is beautiful, right? It generates all those types for us and whatnot. However, it is limited. It doesn't support interfaces. Custom scalars are parsed as JSON.t. There are a few weird edge cases. Those are more or less from just a lack of time. They're not impossible. So, and the other thing is that because of the way the PPX works, it's unlikely that we'll be able to get kind of autocomplete like you see here. If I say description HTML, for example, this right here would be lovely to have directly inside of my editor as I'm writing my query there. I would love to actually just be able to get rid of graphical and just live inside of my editor. But with the way the PPXs work, this might be a little bit challenging. The other big thing is syntax. This is a bit of a pet peeve of mine. But any of you guys who worked with the GitHub API yesterday will recognize this, where I'm calling out some repos. I'm going to switch off of the response, and I'm going to pull the viewer. I want to know the viewer that's currently logged in. But they might not be there, so I have to switch, and I'll pull out the viewer. And I want to pull out the repositories, but they might not have any repositories, and so on and so forth. And this goes on and on. This actually is like cut off. This goes on and on and on. It's this lovely descending tree. So again, this is just like whenever we were first working with the JSON parsing. It's good to get it safe, and it's good to make sure that it works. Now we just need to make it as easy as possible to use. And so one option would be you can do inline or infix operators. That's definitely a way to go. Another one is adopting, for example, the Rust syntax for dealing with result and optional types. The idea being here that whenever you access a field that's nullable or an option, you add a question mark here, and if any of these are null, if any of them are none, it will return none immediately. And if none of them are none, then the last one will be some of that last thing. So we can kind of take this safe thing, and we can make it as easy and succinct as possible. So this is kind of the dream of what I want to be able to write. On the back end, however, the OCaml GraphQL server is still very, very young. It's primarily the work of one very intrepid gentleman from Copenhagen. It's still unclear about how you marry the two type systems and propagate errors properly. We haven't implemented subscriptions or directives, and there's a wider GraphQL ecosystem that we don't necessarily integrate with right now. And that's just for lack of time, not for any sort of impossibilities there. And just as a caveat, the reference implementation is in Node, and it's GraphQL.js, and we're probably always going to be behind that. So there are definitely trade-offs whenever you use OCaml. And I would say that there are some really, really big implications of GraphQL and typed languages. So just as before, I would say whenever we reached outside of the outside world, it was incredibly painful, and it meant that you basically had to stay inside of your own domain. And this makes it as easy or easier than dynamic languages to access all these outside world, real-world data, and to build real applications that interact with the world. So we don't have to just make compilers, and we don't just have to make UIs. We can make things that actually deal with real-world APIs. And I'd give a demo of OneGraph here. This is a quick demo, and it's quite fun. So the idea here is, what if Reason had access to all of these different APIs, right? So you have tons of APIs. You have Stripe, and you have Salesforce, and GitHub, and all these different ones. And if Reason had a GraphQL wrapper for them, then we could actually access all of them super, super trivially. So let's say, for example, I'll give you an example of what that would look like. So if I could access, for example, maybe I'm writing an application that wants to pull out some information on a YouTube video given its ID. So I'm going to go ahead and run this, and I get the ID back. Maybe I want to pull out the title of this video. So I pull that out, and I can get the channel ID. And this is typically where REST would end, right? Got the channel ID, and now we make another request to another REST endpoint. But really, we just wanted the channel. So I'm just going to hop over to the channel. I'm going to pull out the title of that channel. So I traversed 2 different API endpoints there. And the cool thing on YouTube is you can associate your channel with external media, things like Instagram and Twitter and whatnot. So for every Twitter link that this YouTube channel is associated with, I want to hop over into Twitter. I want to pull out the 5 most recent tweets. For each of those tweets, I want to pull out the entities. And now we're in the Twitter part of the API. And the Twitter API has this idea of entities. This would be like any user that was mentioned in those 5 tweets. I want to pull out their screen name. And I want to pull out their 5 most recent tweets. And now for each of those tweets, I'm going to pull out the text. And the obvious thing to do here, having gone from a video to a channel to all of the Twitter links to all the followers to all the edges, is that if anyone tweeted about a video, we obviously have to hop back over into YouTube and pull out the title of that video. So I'm going to run that. We're going to make 30 or 40 API calls across all these different services. And we're going to mesh it all back together in one single response. And there we go. And so being able to access all of these different So for me, the dream is being able to access all of these real-world APIs with all the type safety, all of the convenience that we saw from this, not having to go through the JSON boilerplate and then the dangerous runtime implications. This is huge. This is very similar for me when I was working with ClojureScript. And David Nolan said that for him, even though he was the maintainer of it, it was basically a fun project. It was interesting, but until React came along, it wasn't real. Because as soon as you touched the mutable DOM API, all of your beautiful functional programming went to hell, right? And React actually enabled us to have that functional interface with a DOM so that we could have all of the beautiful things like OM. And suddenly there was a new domain opened up for ClojureScript that allowed it to be way, way more efficient and way more effective in actually building real products. And so for a reason, I think GraphQL is a very similar thing. So I would encourage all of you to go build GraphQL APIs for your services so that we can enjoy them as Reason developers. Thank you.